What's up guys, it's me again, Sir Ernest, and today we're going to demonstrate to you our third virtual experiment entitled Resistors in Series and Parallel. So as I mentioned earlier, the objective of the study is to find the total current and the voltage across across each resistor or in a series and parallel circuit. So this is the materials that we're going to need. We're only going to need this virtual lab provided by PHYS Interactive Simulations available at this URL. Okay, so let's go straight to our URL. Okay, so as we can notice, we are going to do 4 circuits. You're already familiar with reading such circuits from your senior high school. Okay, so right now we are loading our simulation. So as I mentioned here, this has an online and offline version. So if you want to do this online, you can just go to this interactive simulation. However, if you need to go to do an offline version, for example, if you have a problem with your internet, you can go to your PHYS simulation, PHYS simulation. Okay, so you go to physics PHYS simulations, and then you're going to go to the circuit construction lab, and then you can just download here. Okay, so let's do the online version. So this is your online canvas or working area. So what we're going to do here is we have a list of components in a circuit. So we have some wires, a battery, resistors, a switch if you want to use a switch. You can have a fuse, another kind of battery, high voltage battery source, or a high capacity resistor, or maybe a paper clip, a dollar, a coin, whatever. Okay, so in this case we're going to do this in a simple way. So we're going to use a wire, a battery, and some resistors. Okay, so some options here that you want to use, you can look into the voltage, you can check in the values here or not. Later we'll see what happens there. We have a voltmeter and ammeter. Okay, so the goal for each circuit is to, number 1 is to measure the current flowing through each of the resistors, and then measuring the voltage across each resistor, and then finding the total current and the total voltage. Okay, so but before that, let's look at the table of resistances. Okay, so all in all, we will use 3 resistors for each circuit. So how do you going to determine the value of the resistance for each resistor? So here we're going to use your student number. Okay, this is to make sure that you will use different resistances so that you will be able to practice this individually. Okay, so how do we determine? So looking at your student number, the 5th and 6th digit of your student number is the first resistor. The resistance of your first resistor. The 7th and 8th will be the resistance of your second resistor, and the 9th and 10th digits is the resistance of your resistor number 3. So for example, if your student number is 2020 1, 2, 4, 5, 7, 8, so that means 12 ohms is the resistance of resistor number 1. 4, 5 is the 7th and 8th digit of your student number. So that means 45 ohms is the resistance of your second resistor. And then the resistor number 3 will be 78. And you're going to use this for your resistors when you construct your your circuit. Okay, this table, your equivalent resistances, is when you're going to compute theoretically the equivalent resistance for each circuit. So for example, circuit number 1 is series, so that means you're just going to add our resistances algebraically. So that becomes 12 ohms plus 45 ohms plus 78 ohms, and the equivalent resistance is 135 ohms. So please do not forget to put in your unit in ohms. Okay, so you can do the same for circuit number 2, and as a practice, you compute for circuit number 3 and circuit number 4. You don't need to show resolution, just put in the value of the equivalent resistance for the rest of the circuits. Okay? Okay. Now, let's look at this. Let's try to do the first circuit. Then it's your task to do the rest of the rest of the circuits, parallel and the two combination of series and parallel. Okay, so this is just to demonstrate to you how to use this simulation. Okay, so right now we have resistors in series. So that's R1 is connected to R2 is connected to R3. So let's start building our circuit. So let's start with our battery. Okay, so this is your battery. The longer wire, the longer line is the positive terminal. So in this case, this is the positive terminal of your battery. So we just click and you're going to drag. Okay, so these two circles are the terminals of your battery. Now, in order to calculate or determine or measure the current flowing through the total current flowing through the circuit, you have to add the ammeter right beside your component. So this is your combination. This is your current reader or your ammeter that will determine the total current in the circuit. Okay, next, resistor 1 here, and then we write here your second the ammeter for your resistor, and we do the same for resistor number 2, and then you have your ammeter here. Okay, so what you can do here is we can actually make this circuit bigger, and then if you want to reduce the size of the components here, just press Control, and if you're using a mouse, just scroll down. No, okay, it's okay. Yeah, okay, so just use the magnifying glass here. Okay, okay, so let's do this. Okay, and then okay, so this is your second current, second resistor. So this is the first resistor R1, this is resistor number 2. So we connect your ammeter here right after your resistor, and this is another resistor, and we put in your second current, your ammeter here. Now to adjust the resistors, you just click here, and then you just use the slider to adjust the resistance. So in this case, the first resistor is 12 ohms, so you just slide here to arrive at 12 ohms. This one should be 45 ohms. And this one should be 78 ohms. Okay, now let's finish the circuit by using a wire. So when you drag a wire, so you have two terminals for the wire, so you may just drag one of the terminals like this, and then connect it here, and then this terminal is to click and drag here. So this is now connected. Then make another wire like this and like this. Then you can make another wire like this, and then you can make another wire here, connect it here, and connect it here. We're going to use two more wires, so you don't have to use a switch because it's just a simple circuit. And we have your resistor. Now make sure that you entered the correct voltage. Okay, so I'm not going to write it here, but we're going to use 12 volts of battery. Again, I'm not going to write it here, but I'm going to write, for your experiment right today, you're going to use 12 volts of battery. Okay, so as you will notice here, we now have a complete circuit, and if you're going to notice, okay, let's look at the circuit in a more detailed manner. So as you will notice here, the show current option is checked. So you will notice that the electrons are actually moving this way. If you're going to check the conventional current, you will see that this is opposite the direction. This is the conventional current as discussed in your lecture. Conventional currents points in the direction as if the charge carriers in your circuit is a positively charged particle. However, in reality, we know that it is the electrons that are freely moving in a conductor. So the direction of the current is flowing in this opposite direction. Okay, so this is just for your appreciation. So in order for a circuit to be cleaner, let's uncheck this. Okay, and we have a clean circuit, because what's important to us right now is the reading of the current and your voltage. Okay, so let's start with the current. So the current flowing through R1, R2, and R3, as you will notice, as you expect, is the same because the resistors are in series. Okay, just type in 0.09, 0.09, 0.09, and for the total current, which is the current flowing through just beside your battery is 0.09, which is what we expect. Okay, however, the voltage, we're going to use your voltmeter. So this is your voltmeter, and you have two probes. Okay, so the black one is for the negative side, and the orange one, or the red wire, is for the positive side. And as I mentioned earlier, this side of the battery is the positive side, and this side of the battery is the negative side. So if you want to measure the total voltage across a battery, so we just drag this probe to the negative side like this, and drag this probe to the positive side, and you'll end up with positive 12 volts. As you will notice here, as we expect, because we set the battery to be 12 volts and we set this battery to be an ideal battery, so that means there's no internal resistance, so the voltage across these two terminals would still be 12 volts. Okay, now we do the same for R1, R2, and R3. So for R1, just drag this part here, because remember that your resistors doesn't have a polarity, so either side you will still get the same resistor. However, the voltage should be applied like this. So if this is the negative side, so this should be your positive side. So the voltage here is 107 volts, 1.07 volts. Okay, and then we can do the same here. So this is 4 volts, and we can do the same here, and here. Remember, this is your resistor, not this one. Okay, connect one terminal here or here, you still get the same potential difference. So this is 6.93 volts. So if we're going to add these three values, 1.07, 4, and 6.93, you'll end up with 12 volts. Now on this side is the screenshot of the circuit with voltage reading across R1. Okay, so if you want to do that, you have to go back here, and you have to go back here. You can, as long as you can see this reading 1.07, take the screenshot. Again, you can use the snipping tool, so Control Shift S, Okay, and then you get up with your print screen. Okay, so control, sorry, shift print screen. Sorry about this. Okay, sorry. So this is no. Print screen. Okay. So we'll end up here. You can just do your own print screening. So copy, scrap. I'm using PicPic for my screenshot services or screenshot activities. So copy, and then we place it here. As I mentioned before, make sure that you resize in order resize your figure to fit in the space, and that is your result for table number 1. Okay? Okay, sige. Okay, for parallel circuit, table number 2, and for combination of series and parallel, please refer to the table here. Okay, and then just read the current and voltage, and then you observe how are the current and voltages are related to each other. Okay, so you're going to answer these conceptual questions, and then you're going to answer these problems on. Okay, so make sure that you place your answer here with correct units, and you show your complete solution using an equation editor in this part. So again, as I mentioned before, for the conceptual questions, you may answer in the spaces provided, and they may occupy up to 3 lines. Okay, again, save your worksheet as a PDF before submission. Okay? Okay, so that ends the demonstration for resistors in series and parallel. So I hope you learned the virtual experiment, and I hope you watched the lecture video that I provided to you as well. Okay, and then I hope you will enjoy this experiment. Okay, for now, that's all for now, and I'll see you guys in the next experiment. Bye-bye.